All right, welcome to class, everybody. This is 4.6, inverse matrices and systems of equations. It's a big section, very important. It's the last one of chapter 4. So make sure you take good notes on this. There's a lot of things that haven't come your way. This will be a lot of new material. Okay, here we go. We're going to talk first about this identity idea for multiplying. So with real numbers, the identity number is a 1. So 1 times 4 is 4. But with matrices, we use what's called an identity matrix, and you see the definition at the bottom of the screen. If we multiply a matrix, a 2 by 2, 1, 2, 3, 4, by the identity matrix, it's a 1, 0, 0, 1. That's going to identify the same matrix we already had, 1, 2, 3, 4. So I hope you see that, and hopefully it makes sense. If you actually did multiply these together, whether it's with your calculator or by hand, you're going to see that it comes out the same. So here's how you make an identity matrix. It has to be a square matrix. A square matrix that has a diagonal of 1s. So on that diagonal, it's always a 1. Where you don't have a 1, it's always a 0. That's pretty simple. So a 4 by 4 has that diagonal of 1s and all zeros everywhere else. Any matrix times the identity matrix will be that matrix that you used originally. All right, keep that in mind. And we use the letter I for the identity. All right? Let's go to the next piece. Pretty busy board, but kind of just follow with me. Inverses. So the definition up here is when two square matrices product is equal to the identity. So when you multiply one matrix by another matrix, and you actually get that identity that we just talked about, 1, 0, 0, 1, or a 3 by 3 or 4 by 4 version, then you actually have discovered that those two matrices are inverses. So let's look at it. If we have matrix A, the inverse of A is going to be noted as A to the negative 1. I hope you see that. So the inverse of A would be A inverse. So follow me on this. We're going to use letters. If A times B actually comes out to be the identity, then we know that B is the same thing as the inverse of A, or the other way around. We know that A is the inverse of B, okay? Because their product, their result, was the identity. So here's an example. Determine if two matrices are inverses. So here's X, you see that one, and here's Y. Now, we're going to multiply them together, and I'm going to use that fancy multiplication we did by hand. You guys can do this by hand, or you can do it on your calculator, and you'll see how this works in the end. So my first one, I want to discover if X times Y is the identity. And if that does work, then I'm going to check and flip them around. If Y times X is equal to the identity. If this one does not work, I don't have to do the second way. I know they're not going to be inverses. Here we go. When I multiply these out, you can see the results. I get 1, 0, 0, 1. Good. So I move on to the next part. Over here, I check Y first times X. So when I do that, I also get 1, 0, 0, 1. So because they both come out to be inverse or identities, I know that the original matrices X and Y are inverses. Okay? And remember what I said, the first one you did, let's say it was not 1, 0, 0, 1, then therefore you would stop and say, no, they're not inverses. But because it did, you had to do the second portion and flip the X and Y. Okay? Next slide. Thirdly, so let's just try to figure out if we have a matrix, what is the inverse of that matrix? So the inverse of a 2 by 2, if you have A, B, C, D, here's the formula. A to negative 1, that's the A inverse, equals 1 divided by AD minus BC times the matrix D, negative B, negative C, A. And these letters come from that up there. So what you're going to do is you're going to switch the A and the D, and you're going to change the sign of B and C. Don't put B down where the C is. Notice they stay in the same spot We just changed their sign. So if they were positive, make them negative. If they were negative, make them positive. But for the A and the D, you actually switch those. You might need to rewind that and listen to me say all that again. I want you to notice that if AD minus BC equals 0, you can't divide by 0. So there's no inverse if that happens. All right? And also recognize that AD minus BC is simply just the determinant of your original matrix, A. So find the inverse, if it exists, of P equals 7, negative 5, 2, negative 1. So here's what we do. I went ahead and found the determinant, and it's 3. All right? 7 and negative 1, minus negative 5 and 2, negative 7, negative 10. I subtract them. Negative 7 plus 10 is 3. So I put that over here. 1 over that number, 1 over 3. I switched all my numbers around. Negative 1 and 7, they switched from the original problem, negative 1 and 7. And my 5 was negative, now it's positive. My 2 was positive, now it's negative. And I multiply it like a scalar quantity, 1/3 times the rest of these. Okay? So there's my answer. It looks kind of funny. All right? So pause the video if you need to re-look at that. Alright, last but not least, maybe most important, this is another way to solve a system of equations. This is called matrix equations. Let's look at this system. If I have the system x plus y equals 4 and negative 4x plus y equals 9, I can rewrite that with matrices. Notice how I put in blue the x plus y and negative 4x plus y before the equal sign equals just the 4 over 9. So if we take the blue and we put it into its own matrix form, I'm going to make a coefficient matrix of the 1, 1, negative 4, 1. You see that right there. Times the x and the y in a vertical column matrix that's going to be called our variable matrix. So that's going to equal the 4 and the 9 again. Okay? Constant matrix. So have this listed on your paper. To solve for the xy, multiply on the left of each side by the a to the negative 1. Okay? So what we're going to do, I'm going to show that in black. We can't divide, so we have to multiply by the inverse on each side. So division shows up like this. You take your matrix again, 1, 1, negative 4, 1, and you multiply on the left, like I said, by the inverse of that matrix. And I'm going to show it just with a negative 1 up top. And you continue to put your x and y equals. And I'm going to put my 4 and 9 right here, but I said on the left of each side. So I'm going to put the same thing I did on the left over there on the left over here. Now on your calculator, you're going to crunch this out, and I'll show you how to do that in class. But you could also do this all by hand. I'm not going to show you that in the lesson, but we can do that in class. In the end, you're going to get xy equals negative 1 over 5. So x is negative 1. And y is 5. So therefore, you have a POI at negative 1, 5. This is another way to solve a system. I want you to realize that by multiplying this matrix right here by its inverse, what happens is they end up kind of canceling out, and you just get xy. And the result of negative 1 and 5 comes from this right here. Lots of information, so make sure that you study this over, rewind it. If you have any questions, bring it to class, and use these examples as a guide, okay? Good luck with this, and I'll be around to help in the mornings. Watch the video, all right? Always remember, flip, don't flop.